This module is about Spring Cloud Bus and how we use it to apply configuration changes dynamically to applications while they are up and running. First, I'd like to explain the nut that we're trying to crack, dynamic configuration updates. Once we have a good understanding of the problem domain, it will be easy to understand how Spring Cloud Bus addresses the issues involved. And last, we will take an in-depth look at the details of how Spring applications can refresh themselves and what are some of the things to think about. Now, a few chapters back, we introduced Spring Cloud Config, and we've been using it in our labs ever since. Remember, it is a centralized server for serving up sets of configuration information. The configuration files themselves can be backed by source control. Spring Cloud clients connect to it automatically over HTTP and retrieve configuration information at startup time. The key thing here is that this connection is done at startup time only. So what if we have a configuration change that we need to make after an application has already been running for a while? What if we want to increase the size of our database connection pool or change the logging level of something while it's in production? The approach commonly used for most folks using Spring is to bounce all of the affected applications, basically to restart them all. And this will repeat the Spring startup process. And this is manageable, but it's hardly convenient. Now, out in the industry, various individuals have invented all kinds of homemade solutions to this situation. One thing we could do is have our apps periodically poll the server or some other source for changes. After all, they're polling Eureka, so what's the harm in another heartbeat? Well, this will work, but configuration changes will probably be relatively rare, so maybe it's not a good idea to burn up all that bandwidth. A cleaner approach would be to somehow push the changes out from the server. And this is exactly the space that Spring Cloud Bus addresses. Spring Cloud Bus is used to push configuration changes from the config server to the client applications using messaging technology. So with that introduction out of the way, let's explore Spring Cloud Bus. Spring Cloud Bus is a solution that enables a Spring Cloud config server to broadcast changes to Spring Cloud clients. As such, it eliminates any need for clients to poll the service periodically. It is based on messaging technology, and at the time of this recording, which is early to mid 2015, the only supported brokered technology is AMQP, but perhaps others will come in the future. Basically, the Spring Cloud config server publishes messages to the broker, and the clients become subscribers to the changes. Setting up Spring Cloud Bus is surprisingly easy. The first thing on your Spring Cloud config server, and I emphasize this, the server, because the documentation doesn't really point this out, simply add a dependency for Spring Cloud Starter Bus AMQP. That's all you need to do on the server. Now on the client side, and this is really interesting, you add the same dependency that you put on the server. The code in the dependency is smart enough to understand that if it's on the client side or on the server side, it just works. Now, this presumes that your client is otherwise enabled to use the Spring Cloud parent or have the equivalent dependency management section. We've seen both of these in the last several chapters. Each chapter had the same thing presented, so I won't repeat it here. The next step, we need an AMQP server to provide reliable messaging. You have your choices here, but for the upcoming lab, we'll use RabbitMQ. RabbitMQ is a really nice little broker. It's open source and it's very popular, but the reason I like it is that it's very easy to download and run, which is going to make the upcoming lab really easy. Now, by happy coincidence, if you are running your exercises on localhost, which we have been in our labs, your bus-enabled clients and servers will know automatically how to connect to RabbitMQ, so that will save us a lot of configuration. So when it's time to make a change to your running application, here is what you do. First, you make the change to the relevant files in the repository. Now, when you commit these, there is nothing in the config server that notices these changes. It doesn't do any polling or listening to your repository. But if you were to make a REST call to the config server, it would reread your files and pick up the changes. Next, what you do is you make a post to the bus refresh endpoint on the config server. Notice that this is a post, it's not a GET. So simply firing this URL from a browser isn't going to work. You need to use curl or some type of REST client. I use a REST client in the Chrome browser. When the refresh is requested, the config server is going to reread the repository, but more importantly, it's going to post a message to the message broker. The message broker ensures delivery to all the subscribers, which is basically all of your clients that have the Spring Cloud Bus dependency. There are ways to fine-tune which clients get what, but I'll leave you to look that up on your own if you're interested. And finally, each individual application goes through its refresh process. Now that refresh process, I'd like to explore how the refresh process works in greater detail. At first glance, it may seem obvious, but there's more to it than you might think. Spring Boot applications can be refreshed at runtime. Spring Boot contains a starter called Actuator that we have already seen before in this course. Actuator provides a number of useful web endpoints. For example, when we discussed Eureka, we said that we can send a health check URL, if you recall. Well, Actuator actually provides such an endpoint that we can use for health check. And the Eureka client provides it automatically to Eureka as long as we have Actuator on the class path. That's great. When you have Actuator on your class path, you also have a refresh endpoint. Now, if you were to make a post request to this endpoint, this would be interpreted as a command to refresh the application. Again, I'm emphasizing this is a post, not a GET, so you can't fire this from a browser, even by accident. So use curl or some type of REST client. Now, refresh is not quite as simple as just reloading the application context from scratch. After all, if you think about it, your application could be up and running and could be very busy. It could be processing hundreds of HTTP requests with dozens of database connections, so there are some delicate use cases to think about. Out of conservatism, the refresh only affects beans that are marked with @configuration properties or @refresh scope. And the only other thing affected is logging level. This is because logging level is something that you would conceivably change fairly often in production, and there's really no consequence for changing this on the fly. Now these other two annotations, the configuration properties and the refresh scope, these might be new to you, so let's take a look at these in closer detail. Configuration properties is not something new in Spring Cloud. It actually comes to us from Spring Boot. It is an easy way to set multiple properties quickly instead of putting the @value annotations on each one. So if you have a dozen variables to set using @value, this can get really old really fast. So instead, if you look at the code here, you can see that if we annotate the entire class with configuration properties and supply a prefix and provide getters and setters, really only setters are needed in this case, Spring Boot at startup time will automatically populate these properties with corresponding values from a property source that match the prefix and the name of the property. You can see this YAML file has a section that matches the prefix that we are using, and properties in the file line up with what we need to set. Extra properties that we might have would be ignored, and anything without a setter would also be ignored, both of these silently. Now, an interesting feature of this is what is called relaxed bindings. If you notice, the spelling of lucky word here does not exactly match our property name. And this is actually okay. In fact, I've done it for illustrative purposes. Spring Boot actually understands what we mean. Spring Boot is going to be forgiving with us as far as the names of the properties. Camel case is also okay, and all caps would also match this property. Now, if you do a post to /refresh, any beans with @configuration properties will have their properties rebound. And that's wonderful. But realize, however, that there's a limitation here. It might not be enough just to reset those properties. You might have some initialization logic that needs to be rerun and such. Now for our controller here, rebinding the properties is completely fine. You can see that the property is just used in the logic in the controller, so it's perfectly fine. Now something new that was actually introduced in Spring Cloud, not part of Spring Boot, but Spring Cloud, is called Refresh Scope. This is actually an additional scope to the ones that we commonly use in Spring, things like Singleton and Prototype and so on. Refresh Scope gives us the ability to safely and completely reload the bean without having to worry about the effect that it will have on other beans that are presently referencing it. See, the configuration properties was just about property binding and rebinding. But Refresh Scope allows for hot swapping of old and new copies of the bean at runtime. So when you post to refresh, the entire bean is reloaded. It isn't limited to property rebinding. Now, it's reloaded in a safe way. And I'll illustrate that in the next slide to show you how it works. An interesting side effect of this is that the bean actually becomes lazy, meaning that it isn't actually reloaded until the first time that it's actually used. This is usually okay, but it does mean that any configuration issues or post-construct issues won't be discovered until the first time the bean is actually used. And that might catch you by surprise. So beware of that. So you can see from this code our bean uses refresh scope. You can also see that I've reverted back to value annotations. We can use configuration properties with refresh scope, but this just helps illustrate the differences more clearly. With the @value annotations, I don't really need getters and setters, but I do lose the relaxed property binding that was provided by Spring Boot. Refresh scope works by using the proxy pattern, and it is one of the really great use cases that you will find for this pattern, so I'd like to go through it. When the application context loads, Spring creates a proxy for the actual target bean. The proxy either implements the same interface as the target bean, or it extends it, depending on whether an interface is present on the target bean. It has the same method signatures as the target bean. Main point is that the proxy looks exactly like the target bean to anyone referencing it from outside. Now, when we do dependency injection, other beans do not get the original bean, but they get a reference to the proxy. When the caller makes a method call, the proxy simply turns around and calls a method on the original bean. Now on refresh, what happens is a new replacement bean is created, and the target reference on the proxy is switched to the replacement. Any calls to the original bean are unaffected. Any calls to the original bean that are currently executing are unaffected. They can finish up their work in peace, but any future calls to the methods will go to the new bean. The old bean is eventually going to be dereferenced and can be garbage collected. So the beauty of this is that the proxy makes it safe for the existing threads to finish up whatever they're working on, while the future work gets gently switched over to the new version. Very elegant. So now it's time to do an exercise. What we're going to do in this exercise is we are going to set up our Spring Cloud config server to use Spring Cloud Bus. And we're also going to set up RabbitMQ. You can use other brokers, but RabbitMQ will be easy and the instructions are written for it. And you'll see how you can use this to make dynamic configuration changes. So take a look at lab number 8.